Good afternoon, everybody. My name is Roger Teagle. I'm CEO and founder of Cedar Bay. Thank you for joining us in this third in our series of world-class manufacturing webinars that we've been running over the summer. We'll just first of all start with some sort of etiquette for the call. Your microphones are all on mute, but we don't want you to not be able to ask questions. So there's a question box on your GoToMeeting webinar, so you can just enter a question. There's a bit of a delay when they come to us, so we'll answer all the questions at the end. But if you think of a question as you go through, it's helpful for us if you just type them in, and then we've got some questions we can start with. We're recording this, and we'll put this up on our website, and we'll send you a copy with a link after this presentation, so that will be available, and we'll do a PDF of the slides by request if you just contact either Ash on the marketing for Cedar Bay or one of us, and we'll send you a PDF of the slides if you want. We'll ask a couple of survey questions as we go through, just to get a little bit of interaction. It's nice to understand what people feedback about what we've said, but also to give us some information on how we actually hit the mark in our presentation in terms of what we plan to achieve. So just have the next slide, Chris. So world-class manufacturing, we've done a sort of series of these, and they're all around how world-class manufacturing principles, but then really what we can do to change and improve. So world-class manufacturing is all about continuous improvement. What are the opportunities are out there? How can we change and improve? And a great quote from Henry Ford in terms of, if you always do what you always did, you'll always get what you always got. And companies can't afford to do that nowadays. There's too much competition out there, too many agile manufacturers. So we have to keep improving. And really, this session is very much about how IFS supports some of that lean, just-in-time type manufacturing approaches. Just have the next slide, Chris. So what we've done so far, this is third session. We started off a session on paperless manufacturing, which is actually part of the UK user group. Then we did a forecasting and planning one, looked at demand planner and master production scheduling. So stabilising that top level supply or demand, sorry. This one's just in time lean manufacturing, which will cover sort of more the execution side, the sort of shorter term planning and execution. And then we'll go on to the next yet to be run, total quality management and total preventative maintenance. So we'll cover those in future sessions, and you should have information about how to sign up to those. So thank you to everybody. Thank you to everybody who's attended. We've got people from 8 different countries on this. So good morning to those guys in Canada, US, and Mexico, and good afternoon to the UK and European people. And without further ado, I shall just introduce Chris Anthony, who's a manufacturing planning specialist, and he'll run the session. Thank you, Chris.
Thanks, Roger. So this is going to be a webinar where we'll look at lean and just-in-time from an ERP perspective. There's a few slides here to put the spotlight on some of the specific things that you can do with IFS to support any continuous improvement initiatives or journey that you might be undertaking. I'm going to tackle some of the key building blocks in a deliberate sequence, starting with the general foundational principles all the way through to tying IFS into what happens on the shop floor. But before I start, I'd like to get some feedback on where you currently stand with IFS and lean. So here's our first survey question. Do you feel that IFS supports your lean initiatives? So the poll's been open now, and I'll give you a minute or two to respond to that, and we'll see what everybody says.
Nobody's saying anything yet.
It's very, very quiet so far.
Right, got a few.
Okay. Okay, so far we're seeing that IFS is not key in delivering lean initiatives just at the minute. Everybody's typically going for the a little or not a lot. Yeah, so pretty much the results coming in are that 41% of you feel that it's a little involved in your lean stuff. We've got 29% saying yes, it does support them. 18% of you is key, and 12% not at all. So it looks like we've got a decent spread, and it means you should find this webinar pretty useful. So here's an overview of what I'm going to go through. Starting at the bottom of the diagram, lean foundations. This is going to focus on some of the fundamental considerations when organising an ERP system to support lean. And this will primarily look at things like the types and quality of data and how we're able to use our planning tools to create supply chain stability. Variability in demand is one of the challenges of lean, and I did cover handling demand variation in a previous webinar on using the demand planner and master schedules, as Roger indicated in an earlier slide. And if you missed that one, have a look at the Cedar Bay website where you can catch up with a recording of it. Without good lean foundations, we may not get the optimum benefits from a lean implementation. In addition, the master data and output from our ERP system can help to give us some clarity on where to focus effort. So, looking at focused effort, we'll look at how we can utilize those good foundations to help use resources to give us the best possible outcomes. And from there, I'll go through each of these elements in turn, from the suppliers all the way through to manufacturing, and see how to make use of IFS and the CBAPS data capture as well to further support a lean program. We'll look at the supply chain as a whole with opportunities for improved communication upstream and downstream. We'll look at how to use IFS in simple ways to reduce inventory, including the use of the inbuilt IFS Kanban functionality. We'll also look at WIP, and in particular setting a goal to automate shop order reservation and pick lists, having good routing and lead time data being essential for this to be effective. And then what can we do visually with IFS? I'll share a simple method for color-coded priorities that gives instant feedback, whether looking at an IFS lobby or physically in the shop floor area. And finally, we'll look at manufacturing execution, and where IFS and CBAPS provide a very good solution to capture data electronically, giving real-time variance statistics as well as quality control plan input. So in a bit more detail on the foundations and what we should be looking for in IFS. Key information that's going to be useful to support and focus our efforts is going to revolve around understanding the makeup of lead times. For the supply chain, the latest order date is a key driver for ensuring we have appropriate cover for our supplies, while not committing before it's necessary. To establish a latest order date that we can work with, lead time settings in IFS must reflect as real a situation as possible. Often we see lead times are populated with supplier quoted times or an average or a best guess, but where there is high variability in lead times, it can be tricky to identify what this should be. So this really should be defined as time taken to reliably replenish. So that is, it's a lead time that the majority of the time we can rely on, from the point of placing an order with a supplier to the point it's received and available in inventory ready for picking. The same philosophy should be used to set up routings to derive a manufacturing lead time. In order to have a basis for improvement, we must get IFS to reflect reality. And having that realistic picture of what it takes for reliable planning and execution, we can start to see where effort may be needed. And then on that basis, having a stable supply plan where we can buffer our demand variability to protect production and supply plans that give us reliable and predictable results, also give us that firm foundation and understanding of the real situation, so we can reduce waste in areas that will make a difference. IFS can automatically calculate stock levels based on historic variability, and allied with a master schedule, this becomes a very powerful tool for providing that essential buffer against the volatility in demand. The IFS safety calculation is a function of lead time. So if we use IFS to calculate our stock levels, but we're concerned with the amount of inventory required, then focusing on lead time reduction also drives the inventory down. And in addition, we'll look at how WIP inventory is also a function of lead time. Again, reducing WIP becomes an exercise in lead time reduction. And finally, for us to have stability in our supply chain, we must be looking at a close to 100% plan execution. There must be robust planning processes that don't overcommit on capacity, that are based on reliable lead times. And there must be robust execution processes that are proactive and have root cause analysis feedback on any failures. We should be planning for the waste that already exists in the system before we're able to systematically remove it. Any lean journey can spawn a multitude of opportunities for improvement, but there's finite resource, so projects need to be carefully chosen to give an appropriate return. In the early days of a lean program, phases like low-hanging fruit and hearts and minds are often used, and that can help to kickstart a journey. But lean will ultimately need to deliver tangible returns, and that is doing more with less. So using IFS as a tool to identify these opportunities can be highly beneficial. With a lean foundation of good lead time data and a stable executable plan, then we must be able to find waste in the system. Inventory will be buffering for variability all the way through the supply chain, with high WIP and long lead times masking hidden capacity in manufacturing. Using real-time data capture, we can look at that variability in detail. Where is it that we're holding excess buffers of time or inventory to protect us? And this could originate from the demand, erratic customer ordering patterns, from supply with unpredictable lead times or quality issues, and from manufacturing with variable process times or quality issues. Making improvements in these areas will allow us to reduce inventories and the reliance on these buffers. And then having a really good handle on capacity is vital. Identifying the rate limiters in the supply chain from manufacturing and suppliers, and exploiting the constraints to get more throughput with the same or less resources. Reductions in lead time and total WIP inventory here will give further benefits in revealing hidden capacity on non-constrained resources. But we'll need to have a look at our batch sizes and reduce overproduction to get the biggest benefit from this approach. Okay, in supply chain, I want to focus on the relationship between our production or supply plan as generated from the master schedule and the point at which orders are firmed up. So going into a little bit more detail now on the latest order date. The master schedule is in place to stabilize the supply chain as a whole, not just our production. So we're looking at and implementing a planning time fence in a master schedule that covers the lead time of the components as well as the production of the final assembly. And with a stable supply plan, we can communicate to suppliers with a combination of committed orders and also communicated intention, which would be some kind of a non-binding forecast. Stability is the goal, but we do still need to deal with the demands of real life. And to achieve or maintain low inventory, we mustn't muck around too much with the supply plan. And I always recommend a really good change control process for when the inevitable strikes. If you get wild supply chain demand variation, this will inevitably lead to poor delivery performance or the need to hold excess inventory. So with a master schedule in place, the planning time fence should be set to protect the supply chain and require those good change control processes that consider the impact of the change on that supply chain as a whole. Beyond the planning time fence, variation is assumed and will not typically be committing orders in terms of quantities or dates beyond this, other than communication with a supplier to look forward and reserve capacity or help the supplier with their future planning. So looking at the latest order date in the purchase ordering process, first of all, we'll look at how it's derived and why you want to make sure that's correct. I mentioned previously that we need a lead time to reliably replenish, and this is made up of the supply and manufacturing time and the transportation data, both external before arrival and internal after arrival. When a demand is created in IFS, and in this case we're looking at a shop order demand, the demand tells us the wanted receipt date. When does this need to be available in inventory for us to use? So receipt date there. And in creating supplies through MRP or back-to-back situation, IFS works backwards from the receipt date, starting with the transportation data and calendars, and then using supplier lead time against the supplier calendar. And that's how the latest order date comes about. The latest order date needs to be used as a threshold for what orders are being committed beyond which the supplies will remain as requisitions and also subject to uncontrolled variability. To really ensure that the latest order date is calculated correctly, we need to pay close attention to the supplier calendar and the transportation data. The manufacturing lead time on supplier for purchase part is the total time elapsed from the point at which the supplier receives an order until the date it is shipped by the supplier. And the number of days in here is applied to the supplier calendar. If you don't have a supplier calendar specified, then the number of days will be based on a 7-day week, 52 weeks of the year. But sensible application of a supplier calendar can help us to make that latest order date more accurate by taking into account exceptions. So we have shutdown periods such as Christmas or summer shutdowns across Europe, and these can be set up as exceptions on the calendar. And the latest order date will take those into account, ensuring that we have a date that is always reliable. Supplier calendars are also very useful where you have short lead times of maybe less than 2 weeks, where you may need to take into account weekends. And a good barometer for whether you have solid IFS data here is to apply purchase order automation, automatically releasing those requisitions or orders at a predetermined interval ahead of the latest order date. If that would be a challenge for you, then have another look at this lead time and calendar setup and see if you can make those latest order dates realistic. Okay, so let's have a look at the communication of demand to suppliers. This helps our just-in-time approach to have scheduled drops directly into production aligned with the production plan, and also to look out further beyond our immediate plans and have suppliers understand our longer-term needs. And in practice, here we have a series of production demands. Firstly, a shop order, and that's reliant on an imminent purchase order delivery. It's already inside lead time. Then I have a fixed shop order requisition. This is fixed by the master schedule using the planning time fence. And we need to fix that because the purchase order is already placed, and that is within lead time as well. And I'd be saying here that any changes would need to be subject to a controlled change in this case, because it would inevitably end up having to modify the details of that particular purchase order. And then further out, we've got shop order requisitions that are proposals by the master schedule. It's beyond our planning time fence, so requisitions would be variable at that stage, still have the potential for change, but we can still communicate those to the suppliers as some kind of non-binding forecast. And then when we fix up our demand inside the planning time fence, we can firm up those POs. IFS gives us mechanisms for communicating these variable requirements ahead of placing the PO, and we can either do that simply from a list of requisitions, as I've got here from the requisition lines, or you've got supplier schedules, and that can give you more features in terms of a template for the communication, plus that automation of the firming up process. The templates can be configured to aggregate into greater buckets the further out you look, so showing daily or weekly requirements in the near future, and then aggregating up to monthly or quarterly later on. We don't always have or want to have such firm production and supply schedules, and for that we got Kanban. IFS has a complete Kanban implementation that has the ability to calculate the number of Kanbans required in the system based on an expected or actual future demand. The supply signal is initiated at the point of consumption, in my example here by a shop order, but it could be equally from a production line. The components are typically pulled from a shop floor location, line-side storage. And this consumption will trigger a replenishment. In my example here, I've got a number of nodes in the chain. I have a central main stores that will resupply the shop floor, and then the main stores in turn is supplied from the supplier. But you could equally cut out that main store location and have suppliers directly supply the shop floor location. And the entire system is a pull system. So the shop order is pulling from the shop floor, line side, which in turn is pulling from main stores, and in turn pulling from the supplier. The number of nodes in that chain is entirely user definable. You set that up exactly how you want to in IFS. Kanban cards can be printed directly from IFS, and these are referenced with a card number, and they can be audited in operation. These cards can be used in the traditional way, including the barcodes that can be read to carry out IFS stock movements and update IFS with the status of the card. IFS can also generate necessary electronic signals and transactions that allow replenishment to be executed without the need for a physical card to be handled. And in addition, all of these stock movements can be handed over to the IFS Warehouse Task Manager for warehouse planning and execution to take place, whether those physical cards exist or not. And IFS will also create the necessary purchase requisitions and orders for external suppliers. Number of cards in circulation can be tracked in IFS, and when circumstances change, IFS can recalculate Kanban requirements and recommend that cards are removed from circulation or new ones created. And this would also happen for any quantity changes per Kanban. So much like we've looked at the latest order date on purchase orders, I want to have a look now at the shop order start date. And typically everybody likes to focus with shop orders on the due date, which is the need date or the finish date, as this is normally the non-negotiable and most obvious date to be looking at. And strictly speaking, it doesn't matter when the shop order starts as long as it finishes on time. But looking at it through a lean lens, we want to limit our work in progress and prevent overproduction. So we have to take a look at the material release process to ensure that we only put a shop order out to be worked on at the latest possible time. And to do that, we do need to have a good handle on the lead time. So a quick refresher here on lead time construction to be sure that we can get a viable and realistic start date. I also want to note here that's another area of IFS that can be used to help focus effort. It's highly possible that shop order lead times don't accurately reflect the actual time spent on the shop floor. And if you find that you are releasing shop orders to the shop floor way earlier than the start date, then this could indicate an area that requires some attention. Lead time of a shop order is built up using the routing. Here I've got a shop order that shows 3 operations, 10, 20, and 30. The finish date and time of the shop order is the same as the finish date and time of the final operation. And the start date of the shop order is the same as the start date and time of the first operation. Each operation consists of potentially 4 elements of time. First of all, you have a queue time, and this is set in the work center, and it can be set as a buffer, and this will typically be a portion of time that is a buffer before the start of the setup time. And I think I'd like to recognize here that queue time at a work center, even when we're talking about a lean and just in time, it could still be an essential part of the lead time. In particularly when you're looking at a constraint or a bottleneck, you may need to have a buffer ahead of that constraint to guard against upstream supply issues. The worst thing that can happen is you can the constraint could run out of work as a result of a machine breakdown that's further upstream, and that would be highly wasteful and not recoverable. But having said that, the queue time is entirely optional and is set, like I said, on the work center itself. Then the usual operation times, the fixed setup time, which is applied to the entire shop order, and then a variable or run factor that is applied for each unit. Again, we need these times to be reliable. We can't plan effectively if there is high variability in your process times, and these times are set optimistically. And then finally, transport time can be added to an operation as a delay at the end of one operation to allow the transport of the work to move to the next operation. Okay, so that's how lead time is constructed. So we can see now how to get from the finish date back to our start date. And with the setup we have here, the shop order start date time is worked out to be when the shop order is needed in position to begin the first operation. That will include any pre-queuing time as well. And for the perspective of lean, the most important thing is we don't want shop orders to be on the shop floor before the start date. If that is If we can make that the case, that we don't ever put a shop order out until it's due to start, then we can classify our total WIP inventory as a function of lead time. And to reduce work in progress, we just need to look at reducing the lead time. Again, it's an easy way to look at focusing effort in the right place. And a great way to get control of this release is to automate the process. Take out manual administration and have pick lists generated automatically at the point they need to be picked, such that shop orders are available to production exactly when needed. And this example shows our shop order with its start date. And I've set up a process type here called reserve shop order 2 days before start date. And then a scheduled task to create the pick list for the shop orders for all reserved for everything that's been reserved. So automatically 2 days before the start date of the shop order, all the materials reserved, and then a pick list is created, which can be generated directly in the stores function. And I previously mentioned Warehouse Task Manager, and that's really useful in handling warehouse operations for picking, and this approach would help with a capacity planning and ensuring that the stores isn't overloaded at the time that you're trying to pick shop orders. The main purpose of a shop order as well is to book time and materials, and we don't really need this being created much before we need to use it. So it is possible to automate the conversion of requisitions to shop orders as well. I've shown here a window of 7 days before start date, and that gives us 5 days where we can fine tune a shop order at the planning stage if needed, before the parts are reserved and that pick list is printed. Okay, I want to turn our attention now to the visual aspects of manufacturing and where IFS can be used to creatively to support the shop floor. And this slide is something, just an example of something that you could do to indicate a shop order status that would help with decision making and prioritization. If you look at this colored bar across the top, this is meant to represent a shop order over the course of its lead time. We've got the start date there and the finish date there. And then in between start and finish date, it's divided up into thirds, where we've got a green zone, a yellow zone, and a red zone. And then before start date, I would have it colored blue, and that would indicate our excess WIP, as I detailed in a previous slide. If we've got work out before the start date, then we could consider excess WIP, so that would be blue. And then beyond the finish date is the failure zone. This is really, shop orders are really typically referred to as in backlog here, or overdue, or in arrears. But strictly speaking, they're actually a failure to execute. So we should treat them as such. Anytime a failure occurs, we ought to do a root cause analysis performed on that with immediate corrective actions and future prevention, as well as identifying anything else in the plan at risk and that might experience the same problem. The red zone is also a bit of a special case, and this should be your normal expedite zone. As soon as something's turning red, it's top priority in the job of the execution team to ensure it's finished on time and doesn't become a failure. So with some creative application in IFS, we can apply this color coding, knowing the lead time of a shop order and where we currently are in the time span. And I've set up some lobbies here with counters and lists with their corresponding colors, and also some conditional formatting on shop orders. And this gives us some great visual information from an execution and planning standpoint, as well as a management overview. It's very easy to see failures, what's top priority, and also we can see where we have excess work in progress. And all that would be visible from within IFS. And then for the shop floor, we can use that exact same color coding through the use of things like colored containers, shelves, or labels, so that everyone is looking at the same picture. I'd be able to stand in a production area and see the shop orders that are colored the way they are on IFS and know exactly what that means. I should be seeing the reds and blacks being worked on, with greens maybe waiting on the shelf, waiting their turn. And then I'd be asking why we have blues out already, as it's clear we don't need them yet. So a very, very close matchup between what you can see in IFS, what you can see on the shop floor, nice and visual. Then in terms of feedback from execution, variance reporting is also really good for focusing lean effort, helping to drive consistent and repeatable processes. And shop floor workbench is a great tool for capturing real-time activity data. You have a start setup, start production buttons. You've got ability to record downtime for equipment, and also registering interruptions on jobs and any non-productive time, such as training and meetings. So you can have some really good real-life data being fed back into IFS. And you can use that data to compare both as a variance from the standard, but also tracking the scale of deviation between similar operations, so that you can start to reduce down that variation and get something that's more consistent and easier to manage. And with additional data capture integration, using barcodes or digital tooling integrations, such as scales or measuring equipment, more of this data can be pulled in and analysed. And at Cedar Bay, we've recently installed a scales integration with a food manufacturer as a way of capturing the amounts of ingredients being issued to shop orders, for instance. And all of this real-time data being captured can be used to analyse our processes for further lean improvements and used to report successes and also to justify investment. So that's it. We've seen that IFS can provide a solid foundation for just-in-time and lean through stable supply plans and a repository for standardized process timings. We've then seen how to use that IFS data to focus effort through variance and capacity reporting. Having a lean supply chain can be supported with purchase order automation based on a stable plan, including the ability to generate automatic supplier schedules that support just-in-time inventory policies. And we've seen how IFS provides complete pool replenishment functionality with Kanban. We've also covered how shop order automation and restricting release of shop orders can be used in managing work in progress levels, and then how lead time becomes a focus point for further WIP reduction. And we've seen creative use of IFS to match visual shop floor management with lobbies and color coding. And finally, data capture through shop floor workbench and CB apps to be used in variance analysis and ongoing focused lean effort. So that wraps up my session. I hope you found it useful. Back to Roger.
Thank you, Chris. So that's really good. Hopefully gave people some ideas of how IFS can be used to dovetail in with lean activities. We've got a poll question, but just before I ask the poll question, I just want to, if anybody has got any questions, please stick them in your question box. We can then just pick them up after we've run the poll. But just wanted to run a poll question. So based on what you've seen, do you think the concept presented would be useful to work now on your business? Would it provide some elements for useful, or maybe useful, or not at all useful? Just for us to get a bit of feedback on what people are thinking from what Chris has shown. I mean, hopefully, we've done this session to try and expand out the use of the practical aspects of IFS, because quite often people get the basics in, but there are quite a few little aspects of IFS that will be useful to you that we can help you implement. So we've got some figures come through. So we've got a 25% be useful to work on now, 17% provide some elements that would be useful to us, and 58%, or 50, keep changing, 58% said may be useful, but I need to think about that. At least we didn't get anybody with no benefits at all, so that's good. At least we presented some things that are potentially useful to people. Just going to wait for some questions. The questions take a little while to come through to us, so we're just going to see if we get any questions. If we can just go to the next slide, Chris, or our final slide. our contact details are there, or the email info at Cedar Bay if you have any questions that you think of afterwards or want a copy of the presentation. You must have answered all the questions, Chris, or people are thinking about it. So we're not getting any no questions on our poll. Yeah, so if we've not got any questions, thank you very much. Hopefully we'll see you on the next webinar. The next one's TQM, so Total Quality Management, so how IFS supports that element of world-class manufacturing. As Chris said, they're up on the webinars are going to be up on the website, so if your colleagues want to look at what we've done, feel free to use that resource. And any questions, please contact myself or Chris. Yeah, feel free. Thank you very much. Thank you, Chris.